So what we saw in our last problem is this. It's rather unusual to find a man shorter than 62 inches. Only 2.5% of men are shorter than 62 inches. Similarly, it's rather unusual to find a man who is taller than 74 inches. Only 2.5% of men are taller than 74 inches. Well, this gives us some criteria for describing whether something's unusual. We say that a data value is unusual if the data value lies more than 2 standard deviations away from the mean. So like 62 inches. So if the standard deviation back here was 3 inches. So if you move over 3 inches twice, you get 62 inches. And if you were to go to the left of 62 inches, we said you would have an unusually short man. If you went to the right 3 inches twice, went out to 74 inches, we said it would be unusual to find a man who was taller than 74 inches. So usual data values, we say, lie within 2 standard deviations of the mean, away from the mean. Unusual data values lie more than 2 standard deviations away from the mean. Okay, well, let's think about how you compute how many standard deviations something is away from the mean. Like 74 inches. We say, oh, okay, it's 2 standard deviations away from the mean. How do we know that? Well, look, 74 is 6 inches away from the mean. So 74 minus 68 is 6 inches. But the standard deviation is 3 inches. If we divide 6 by 3, we get 2. We figure out that 74 is 2 standard deviations away from the mean. So 74 minus 68 divided by 3 gives us the number of standard deviations away from the mean. Okay, well, a z-score, in other words, a standardized value, is the number of standard deviations that a given value is above or below the mean. Well, now we have formulas for calculating a z-score, or figuring out how many standard deviations something is above or below the mean. You just take the data value, you subtract the mean, and you divide by the standard deviation. So if you have all data, if you knew the average height of all men in the world, or the population mean height, and you knew the standard deviation of all men's heights, you could find a man's population z-score. But if you only had a sample of men, like you only grabbed 40 men, recorded all their heights, well, then you could find a data value's sample z-score. So let's see. All right, so let's work an example. Suppose a sample of men yields a mean height of 68.34 inches with a standard deviation of 3.02 inches and a mean weight of 172.55 pounds with a standard deviation of 26.33 pounds. All right, which is more unusual? A man who is 76.2 inches tall or a man who weighs 237.1 pounds? Okay, well, let's figure this out. So let's look at the man whose height is given first. So, all right, height. We will find the z-score for the man who is 76.2 inches tall. So we will take 76.2 inches, that's our x value. We'll subtract our x bar, 68.34 inches. And then we will divide by the sample standard deviation, which is 3.02. And if we do that, we get about 2.60. All right, now for weights. All right, find a z-score. Z equals, okay, we got to do 237.1 pounds minus 172.55 pounds divided by 26.33 pounds. If you do that, you get 2.452. So we see that a man who is 76.2 inches tall, he is 2.6 standard deviations above the mean. A man who weighs 237 pounds, he is 2.45 standard deviations above the mean. Well, that means the man who is 76.2 inches tall is more unusual. It's less common that you see a man who is 76.2 inches tall than it is to see a man who's 237 pounds. Okay, then I ask these questions. Well, when is a z-score negative? When is a z-score positive? Okay, well, we can just look at our formulas. A z-score will be negative if x is less than mu. Or in other words, if your data value is less than the mean. So, data values to the left of the mean have negative z-scores. All right. So in the problem we worked before, we would say that the man who is 62 inches tall, we said he lies 2 standard deviations to the left of the mean. Well, we would say his z-score then is -2.